So finally, I'd like to talk about water quality and contamination issues. The issue here is that the cities of Pocatello and Chubbuck are mandated to maintain water quality. The water quality has to be within standards if they're going to supply it into the municipal water system, and so the cities have to monitor the water quality on a very regular basis, and if contaminants are found, they need to work to keep that from getting into the system. They can do that by shutting down wells, which is costly if there's not another well to take up that volume needed. Or, in some cases, the water actually needs to be pumped out of the ground and cleaned and then either used or put back in the ground. So any of these factors cost money, and that is one of the big issues with contamination. There are the health issues, which is why the standards are as they are, and then there are the cost issues when the city has to address this issue. So first of all, most people in this valley will be familiar with the trichloroethylene problem, which is sourced at the Fort Hall Canyon landfill, now the Bannock County landfill. The old landfill, not the new landfill. The new landfill is a properly constructed landfill with a firm liner at the base to keep contamination from going into the aquifer, and hazardous materials aren't allowed in that aquifer. The old aquifer on the northwest side of the canyon is an old aquifer. It's an old landfill, and it is not lined, not properly lined, and apparently hazardous materials, including a solvent called TCE, trichloroethylene, were dumped there back in the pre-1980s era when these things were less regulated. That TCE is coming out of the landfill into the groundwater system in the canyon, and then that feeds into the valley. And once it reaches the valley, it has moved fairly quickly to the north. This orange line, it connects all the wells, all the city wells that have had TCE contamination of whatever levels, and that is the travel path of that plume of TCE. That's the TCE dissolved in the groundwater. It got up as far as Oak Street, and has cost the county and the city quite a lot of money, as I'll mention in a moment. 8 of 24 city wells, the city has 24 wells, 8 of them were affected, 4 had to be taken out of service. Some of those came back online, but some, 1 or 2 had to be replaced. So this TCE plume was remains a very costly endeavor for the city and county. TCE is known as a fairly dangerous chemical. It has an allowable limit in groundwater of 5 parts per billion. That would be 1 teaspoon of water put into the large Olympic-sized swimming pool at Lava Hot Springs. Just for an analogy, it's a very small amount of contamination that's allowed in the drinking water. So here's what has happened with TCE in city wells over a period of 12 years, ending in 2008, starting in 1997 on the left, July 1997, July 2008 on the right. This is the amount of trichloroethylene in the city drinking water wells in parts per billion. That legal limit that I mentioned is this straight yellow line. That's 5 parts per billion. And we can see that the numbers go up and down. There are a lot of fluctuations in the values in the aquifer. But generally, the good news is that we see after about the year 2000, the levels in the wells are all below 2. This is well within legal limits. We'd like to have 0, but it's well within the legal limits. We don't necessarily understand why it has gone down, but it has remained fairly low through the past decade, except in one well where it went up high and has remained a little bit higher until recently. The county is working to remediate this problem at the landfill in the Fort Hall Mine Canyon. They have a cleanup system there, an air stripping tower, and that is working to try to clean up the solvent coming out of the landfill, cleaning it up near the source, and trying to minimize the contamination going into the valley aquifer. The bad news is how much this has cost Bannock County and the city of Pocatello, meaning local taxpayers and ratepayers ultimately. I won't go through all the details, but until that cleanup system was put in 2001, these are the costs that had been incurred by the county. The cleanup system, the remediation system, has cost about $350,000 to put in. That totals about $3.6 million. And then this system will be running for 30 to 40 years. It costs $15,000 or more to run that per year. And so in our landfill rates for the foreseeable future, for at least decades, that cost will be added in to the cost that the county charges, or that the county pays to run the landfill. And there were some additional removal wells installed in December. Those cost a little bit more, and so the county is looking at least $4 million, it appears, to address this problem. City of Pocatello, $1 million for various activities related to it. So the local cost of this problem is about $5 million, and that is a good example of what happens in terms of costs when we get contaminants in the groundwater. It's much cheaper to keep them out. This is a legacy problem from the old landfill that we'll be dealing with for quite some time, and we want to be sure we don't leave any more of those in the pipeline for the future. Very briefly, fuel storage is also a risk to groundwater. Old underground storage tanks at gas stations were made of steel. They tended to corrode and leak gasoline into the groundwater. Every red dot on this map is a gas station that had a leaking underground storage tank and put some amount of gasoline into the ground. Any one of these could have turned into a big problem. Mostly this is also a problem of the past because these tanks have been replaced, although the storage of any hazardous waste in the city, if not properly stored, is a contamination issue, and so we need to know what's out there, and we need to know that it's being carefully taken care of. If we look to the north end of the valley briefly, much of this presentation is about the main Portneuf aquifer, but the city of Chubbuck also has a solvent problem of unknown source that is called PCE, and they have in this blue area, there's an area of concern for PCE, another dangerous solvent. On the Fort Hall area, there is a plume of the pesticide EDB, ethylene dibromide, which was discovered about 12 years ago and covers some portion of this lighter blue area, and so there are serious contamination issues they're dealt with up there. Chubbuck does treat one well for PCE contamination, and Fort Hall town site at least is on a municipal water supply system to replace water contaminated with EDB. The city of Chubbuck needs to drill a new drinking water well to supply the growth up there, and they have to sneak in between these two areas of contamination. So that becomes a more tricky business when there's contamination in the area. Finally, I'd like to talk the last few minutes about septic tanks and nitrate contamination. The southern valley, southern Portneuf Valley, Mink Creek, Portneuf Gap, the peripheral areas such as South Fifth Avenue, Barton Road, Johnny Creek, City Creek, and so forth. All these areas are on septic tanks. Many of these areas are not served by city sewer, and so the residents have no choice but to be on septic tanks, but this has an impact on our groundwater system. A septic tank, even if it's properly functioning, it does very little to remove nitrates. It may reduce nitrates about 25%. But the rest of the nitrate from the ammonia in the wastewater does enter the groundwater. And if there's an isolated septic tank and enough groundwater flow to flush everything away, that's not a problem. That's how a septic tank is supposed to operate. If there are too many of them in a concentrated area, the concentration of nitrate in the groundwater gets higher and may contaminate other water. So there's the issue of a private well located in an area of septic tanks. That's one issue. Private well owners are required to monitor their own water quality. But if we add a lot of septic tanks through an area, we can very quickly overcome the ability of the aquifer to dilute that nitrate and reduce that contamination. So here's an example of nitrate contamination. This is in parts per million in this case. The legal limit is 10 on this graph here. This is 1989 to 2008. These are the nitrate levels in a well near Ross Park. We can see that through the 90s the levels were fairly low, and then they stepped up, and they fluctuate quite rapidly through the year, but we can see generally those levels are between 5 and 10 parts per million. If these levels go consistently above 10 parts per million, the city needs to treat that water or take that well offline. So the levels are down around 5, but anytime we get into the range of 3 to 5, we have to be concerned. This is a summary diagram, a very messy summary diagram of all the city wells. And so here is that legal limit right here. And we can see that we have a line of 3 parts per million here. That is the level at which we assume that the impact is human, is a human impact. There are very few sources of nitrate contamination in the natural world. It could be livestock, but we have very little livestock in this area. Fertilizers, the fertilizer use is not intensive, and the recharge isn't very large in the valley where the fertilizers would be used. So most of this is almost certainly septic tanks. And we can see that the levels range between, on average, about 3 and 8 parts per million. And if these rise up to 10, the city will be required to treat the water. 11 of the 17 city wells have nitrate levels above 3 parts per million, milligrams per liter. Many private water wells in the South Fifth area have nitrate levels that are higher and that might be a health problem. The concerns with nitrates, nitrate as a chemical causes blue baby syndrome, an oxygen depletion problem in babies. It may cause gastrointestinal problems and cancers. The science isn't terribly well proven on that, but there are some suggestive studies. We in Pocatello have municipal wells that frequently exceed half of the legal concentration. It's very expensive to remove. Preliminary estimates, about $500,000 per well per year, $31 per customer per well per year. That could get very expensive very quickly. And other waste products from the septic systems may also run in there. Finally, to summarize, our aquifer is a highly vulnerable aquifer because of its geology. The Bonneville flood gravels minimally protected by a layer of silt. The water withdrawn nearly exceeds or does exceed the amount that goes into the aquifer. We may be depleting the aquifer. And chemical contamination of a variety of sources has affected our aquifer, and our water is safe to drink. The city does a very good job of keeping it within the standards, but that contamination adds costs. And anytime the limit is reached, the contamination adds costs, and we have to act. Thank you.